Hey, and welcome to this YouTube channel. My name is Sandro, and in this video we are going to talk about how to implement the MongoDB Atlas Search into your existing payload project. Now, you might be asking yourself, why would I want to do that? Well, there are mainly two reasons for it. The first one is performance. So the default payload search uses the regex search operation, and that is perfect for your average collection like pages where you have quite a couple of documents maybe. But as soon as you're working with really large data sets, like 100,000 plus documents, and the documents in and of itself are a bit larger, you start to notice some performance impacts, even though you have everything indexed. So in our case, we had a collection with around 150,000 documents. Each of them was quite large. And the payload search took around 15 seconds to complete. The second issue with that was that the payload search by default actually searches as soon as you type. So the queries ended up getting stacked on top of each other, which led to waiting times of sometimes 30 to 40 seconds, okay? Now, the second reason why you would want to implement Atlas Search is just flexibility. The default payload search uses regex, and that's great in a lot of cases. However, if you want to do advanced stuff like fuzzy matching, etc., and really use the full power of this Atlas search, obviously you'll have to switch to that. Now, generally speaking, the huge advantage that you have with payload is that you can basically just plug in your own React component wherever you want. And obviously that component can do whatever it wants. So it's quite easy to just build a search bar that uses Atlas Search. However, this makes dealing with this collection very complex because you don't just have to replace this whole table and build a custom component. You will also have to replace the default relationship select components where you can actually link a document of the, in this case, contacts collection, because this select component also uses the search. So we were looking for a way how to actually implement the Atlas search into the default component so that the default search bar actually uses the MongoDB Atlas search. Now, after doing some experiments, we actually found a way how to override the default query and replace it with the Atlas search. So we now have a running prototype, and I'm going to show you how to build it step by step. The important part is it's really just a prototype, and the Atlas search aggregation function that I'm going to show you is just a bare bone example of it. But we will be using the MongoDB aggregation pipeline together with the Atlas search. So you really can implement everything that you would want to if you were just using the standard Atlas search. Now, before diving into the step-by-step explanations, I just quickly wanted to show you the default state and what the issue is. So I've created a mock collection of around 100,000 documents. They're quite small, so you won't notice such a huge difference that we did. However, you will still notice a pretty large difference in search time. Let's just query for Hickel, for example. So as you can see, we really have to wait a couple of seconds for the results to show up. Or let's search for Mets. Yeah, now the results are there. Okay, so that is our benchmark that we're trying to beat. Now, how are we going to implement this? Well, the first step really is to create a custom endpoint that overrides the default search endpoint and forwards our request to our own controller function that then uses the Atlas search to query the documents. And that's really step two, creating a function that queries MongoDB using Atlas search for those documents, and then just returns the IDs and uses those IDs to filter a new payload request that then fetches the actual documents. There are multiple benefits of doing it this way that I'm going to explain later. Now, before diving into the step-by-step instructions how to set it up, there is one prerequisite that you have to deal with if you want to use Atlas Search, and that is creating an Atlas Search index in MongoDB. So I'm going to switch over to my MongoDB project here, and setting up an index is very straightforward. You just click on search in this top bar, and as you can see, I've already created my default search index. You will have to just click on create index. You can choose whatever editor you want, JSON or visual. Now with this index, you do have a lot of options here. You can use different parsers. I'm using Lucene here, but for now, we're just going to set up a very straightforward and simple default index. Now, I'll have to set up a second index because the default index is already occupied. But you just leave default there, click on the collection that you want to enable the index for, click on next, and then you just click on create search index. I'm just going to abort this because I already have one here, but it will take maybe a couple of minutes to actually build this index. Now, after we've set up our index successfully, we're just going to switch over to our code. And as you can see, I've just commented out that endpoint to show you the loading time it takes without Atlas Search. So we're going to go through it step by step now. Like I said, the first thing that you have to do is set up a custom endpoint that overrides the default get endpoint. Now, the only thing you basically have to do for that is create an endpoint array and add an object with a method of get. The path you just leave blank, you just set to a slash, and then you link to your handler that we are going to create in a second. Now, what this actually does is if you fetch, /API/contact, this will actually call this handler instead of just the normal get endpoint. So this handler actually enables you to intercept the default request and then just go ahead and decide whether you want to use MongoDB Atlas or not. So if we don't have any search string, then it doesn't really make sense to use MongoDB Atlas. We can just call next and use the default endpoint. But I'm going to show it to you now. So in our handler function, I've just created a basic default export async function. First thing we're going to do is access control, which is very important because custom endpoints in and of itself are not protected. So even if you have enabled access control over here, you still will be able to call this endpoint, okay? Now this is pretty straightforward. Is admin basically just checks if the user in the request body matches a user from the admin collection. In this case, I can show you the code. It's basically just user exists and the user collection is admin users. Now, after we have successfully passed access control, we want to check if the query actually contains a search string. We can do this very easily by just accessing the rec.query object. Now, depending on which component actually sends the request, you're going to either receive an OR query with a name like or a where and query, okay? The and query is sent by the relationship field where you select the relationship, and this query, the OR query, is sent by this default search above the list. Now, you can really add whatever you want, and you can be really specific here. You can also add a custom query parameter that that is only used for the actual Atlas search. Or we could just also include, if we want to, rec.query.where and just name like. So if we just send a regular where query for name and like, this will also use Atlas Search. Now, like I said, if we don't have a search string, or we don't send a query limit or a query page, which happens automatically with the payload components, we just need this one for the request later on. So if we don't have that, we're just going to call next in our custom handler. And if we call next, it will just pass the request to the default payload search function. And we will just use regex search for that query. Now, if we do have a search string, we're going to continue by extracting the actual Mongoose model that we're going to use for our aggregation pipeline. So Payload actually provides the opportunity to extract the model by calling payload.collections with the name, or sorry, the slug of the collection, .model. So now we have our Mongoose model that we can later use to run Mongoose model.aggregate, so our aggregation pipeline. Now, like I said, this is just a very simple example of how such a search query could look like. It's basically just a query for wildcard, which means all path. We could also specify to just say search the name field or whatever. We could also add fuzzy matching, which will actually allow us to have one typo in our request, and it will still match the results. Like I said, you really have all the options here that you would have if you just use MongoDB Atlas. We're going to leave it out for now, though. Now, we're going to pass the search query into our aggregation pipeline. I'm not going to explain how to use an aggregation pipeline here, but it's very straightforward for search. You just add an object for $search with the search query. And the second thing that we're going to add for our pipeline is a project object, which will basically make sure that we only return the IDs and not the full data. The reason why we only need those IDs is because we're actually not going to directly pass down the results that we get from the MongoDB Atlas search to our client, but instead we are just going to use the IDs, which I'm doing here as well. I'm just mapping the contact IDs to a string. Afterwards, we are going to do a fetch request. And this is really the special case. So yes, this is a double query, sort of. First, we're fetching the IDs, and afterwards, we're fetching the actual results with those IDs. The huge advantage of this is that we will actually use the payload access control, because MongoDB Atlas in and of itself will just query everything. We won't have any access control. However, if we use payload to actually fetch the documents, then we will use the default payload access control that we can set in the collection definition for our results. Okay, so what we are doing here is calling the local payload API with obviously the collection and a where query for ID in our array of IDs. So it will basically query for all documents that have the ID that we're looking for. So we're going to get back a list of documents with our search results, basically. Now, regarding limit and page, we're going to just pass it down from the request. Like I said, the default payload component sends those query parameters automatically, okay? So it will just work like we would expect it to work with pagination, also with the amount of results, okay? So that's why we're going to pass this down to our payload query. Now, those two options are actually related to access control. So by default, payload, the local payload query actually skips access control. We don't want that, however. So we're just going to pass a user object, which is located in rec.user, And we're going to set override access to false. So this way we ensure that the user only gets back documents that he has access to. Now, obviously, we have some error handling, but the only thing that is left to do is just return the results with rest.json. Because the cool thing, and that's the second cool thing about doing the payload request, we automatically have the documents in exactly the format that payload would send them back in anyways. To give you an example of that, if we're using the MongoDB Atlas Search, the ID property actually has an underscore in front of it. Now payload automatically maps this underscore ID to just ID. And we don't have to do anything here because, like I said, we're using the default payload query to actually query those results. So yeah, that is basically it regarding the implementation. It is fairly simple. And now I'm just going to go ahead and show you the difference that it makes when actually searching for documents. So let me just quickly comment this out again and restart our server so that I can show you a comparison. Let's search for Botsford. Now we have the result. Okay, and now let's test it with our enabled Atlas search. So I hope you can see that we are having a massive performance improvement. And really the difference is that, let's say you have 500,000 documents. This will further slow down the regex search. However, if you're using MongoDB Atlas Search, you won't really notice a huge difference. So I hope you like this video and everything is understandable. You will also find a Notion page with the actual code to implement this down in the description. And apart from that, I would be grateful for any feedback regarding the content, the teaching style, if everything is clear, because at this point we're really, just starting out. So feedback is the most valuable thing that you could provide us with. All right, take care.